I'm going to give you some tips for post-lab for mastering titration. This post-lab assignment only has 2 questions. The first question is just a table with a bunch of data in it. The first 2 columns, initial and final NaOH volumes, these are things that you recorded while you were doing the experiment. Please notice that you need to have 2 decimal places for all of your burette volumes, or you're not going to get any points. Make sure you have all those in there. The total NaOH column is just going to be the difference between the initial and final. And normally when we're taking a difference, we do final minus initial, but because the burettes are numbered backwards, meaning that a full burette has 0 milliliters according to the marking, and an empty burette is 50 milliliters according to the markings. They're marked backwards. So for this is going to be your initial volume minus your final. Or if that's confusing, just subtract one from the other and make an absolute value out of it. This is going to be the volume that you used of NaOH. Now in this column, you're reporting the molarity of the NaOH. This is something that you will have taken from the bottle while you were in lab. The procedure tells you that the NaOH solution you'll be using is approximately 0.1 molar. So right here it says it's approximately 0.1 molar, but that's not going to be the exact volume or exact molarity of the solution. So don't write 0.1 in this box. This is not what I want you to put. I want you to put the exact molarity, whatever it may have been. And then you will, and I just also want to add that the molarity is going to be the same for all 3 of these. And then you're going to calculate the moles of NaOH, the moles of HCl, and the molarity of HCl from that data. So to help you with those calculations, I'm just going to put some random numbers in here. Let's say that our initial volume was 1 and our final volume was 15.5. And that would mean that our total volume that we used was 14.5. And let's say that the molarity of the solution was 0.179. Let's say what that is. So to calculate the moles of NaOH, we're going to be using the molarity 0.179 molar, which means 0.179 moles of NaOH per every 1 liter of NaOH. This is the relationship that we're going to use. And then we're just simply going to multiply this by the total NaOH that we used in units of liters. So that means we're going to take that 14.50 milliliters and we're going to divide it by 1,000. I'm going to get 0.1450 liters. And this is going to be the way that we calculate the moles of NaOH. So I'm just going to take this hypothetical data and I'll get a number for this, and then we'll move on to the next part. 0.179 times 0.015. This gives me a moles of NaOH 0.00260. Now for the moles of HCl, to get that number, we need to do a multimole relationship between NaOH and HCl. And to do that, you will need the balanced equation for this reaction. NaOH and HCl react with each other to produce H2O and NaCl. And this equation, the way that it's written, is already balanced. 1 sodium, 1 oxygen, 2 hydrogen, and 1 chlorine. So there's a 1-to-1 relationship between NaOH and HCl, which means that the moles of NaOH always equals the moles of HCl. Then the last thing that we're going to calculate is the molarity of HCl, and that's going to be done by taking the moles of HCl and dividing it by the volume of HCl in liters. We just figured out the moles of HCl, that is 0.00260, and the volume of HCl that we used for this experiment was 20 milliliters. Divide it by 1,000 so that it's in liters, and that's how we're going to calculate the molarity, 0.130, like that. Now in your question number 2, it wants you to calculate the average HCl molarity in this spot. I used this spot to write this work. So that means you're just going to add these 3 numbers up and then divide by 3. You're going to show that work here, and that'll be your average.